Hello, good morning, Prof, and all my fellow friends. My name is Tam Mui Hui. Today, I'm going to present about my FYP thesis, title, objective, and the background about my project. My title is Uncertainty of Temperature Measurement. Okay, briefly explain why I chose this title. It is because experiments that involve measurement and equipment that generate data, result obtained will never achieve the exact value of measurement due to uncertainty. Simply say, actually we do not know the true value, so that we use uncertainty to calculate out the result. For previous experiment that involve thermocouple, uncertainty is being considered, but it is complicated. To evaluate the accuracy of experimental result, uncertainty needs to be determined by more easier way. As you can see, shown that how previous experiment conducted. It is done by my senior. She connected each of the wire throughout 15 terminals. Connect all of these one by one. Firstly, she measured all terminal and obtained temperature difference between terminals and internal terminal. Then, only she obtained the uncertainty of reference junction compensation, RJC, is caused by systematic uncertainty. This, I will explain more about it later. So, as a small conclusion, she connected it in series. This kind of progress is quite slow and take time, and it looks complicated and burden to work in chaos. Besides, the internal temperature and room temperature keep changing from time to time, so the accuracy will be affected. Next is about my experiment. I will connect these 15 terminals in parallel. Means that I will directly obtain all the temperature difference between terminal and internal terminal in once. So that I do not need to take so long time to obtain the temperature difference. Then the accuracy of the result might be improved. Yes. Next is about my objective for this project is to obtain the uncertainty due to instrument resolution, fluctuation, RJC, which is reference junction compensation, and the thermocouple measurement. Let's move to uncertainty. What is uncertainty? Uncertainty is essentially lack of information to formulate a decision. Besides, uncertainty may result in making poor or bad decisions. There are two types of uncertainty, which is systematic and random. The main difference between systematic and random errors is that random error lead to fluctuation around the true value as a result of difficulty taking measurement, whereas systematic error lead to predictable and consistent departure from the true value due to problem with the calibration of equipment. But random error and are essentially unavoidable, while systematic error are not. There are two probability will cause systematic uncertainty occur, which is from instrument resolution and RJC. As I have mentioned just now, the RJC. So now I'm going to explain more about it. RJC, actually it is called as cool junction. It's the end of a thermocouple that provides a reference point. Thermocouple measure the difference in temperature between two junctions. They do not measure actual temperature. The sensing junction is where the thermocouple wires are welded together and located at a point where the temperature is desired. The other junction is typically located where it is connected to instrument. This is known as the cool or reference junction. To determine actual temperature, the instrument must adjust for the difference between ambient temperature and 0 degrees Celsius. This adjustment is known as cold junction compensation. Next, it is the main apparatus will be used during conducting the experiment, which is thermocouple. Thermocouple are very common temperature sensor in process. Thermocouple have few benefits that make them widely used. They can be used to measure very high temperature. Besides, the thermocouple is also a very robust sensor, so it does not break easily. The main working mechanism is seatback effect. Okay, how I'm going to conduct this experiment? At first, I will identify specification of instrument used by data logger and thermocouples. Carry out the experiment, connect all 15 terminals in parallel, get the temperature difference between terminal and internal temperature, then obtain the uncertainty at cool junction compensation. If the cold junction compensation is correct, therefore the uncertainty can be obtained from reading of temperature. It determines when the temperature is in 0 degrees Celsius. Lastly, determine uncertainty from fluctuation through standard deviation calculation. Okay, at last, this is the formula to calculate the uncertainty. After gain all the data, an uncertainty will be calculated by using this formula. Thank you for listening. That's all for my thesis presentation. Thank you.